Okay, the next slide. Is the yes, the next slide is the outline of the lesson. Okay, I'm going to be giving learners a definition of matter, explain how diffusion occurs, discuss the particle model of matter in detail, and cite 3 primary states of matter, identify examples of each state of matter in everyday life, and towards the end of the lesson, I'll give learners a summary of the key points from the lesson. And I will conclude the lesson with a short assessment. Now, defining matter. Learners, this is just a revision from the previous grades. Matter is defined as anything that occupies space and has mass. It includes all substances that we encounter in our daily lives, such as solids, liquids, gases, and even plasma. Matter is composed of tiny particles called atoms, which combine to form molecules. Okay, now above there, I talked about space, I spoke about mass, and I also spoke about tiny particles. Now, if matter is made up of tiny particles, then tiny particles usually have space between them. Now, to explain diffusion using the above terms, diffusion would be defined as the movement of particles of one substance from a high concentration to fill the spaces between a substance of lower concentration due to random motion of particles. Meaning, learners, matter can exist in 3 phases. It can exist as a solid, it can exist as a liquid, it can exist as gases. If, for example, you take 2 liquids and you mix them together, we are going to encounter what is called diffusion. It means the liquid that has got the most particles dissolved, the most particles will creep into the spaces of the liquid with lesser particles. And that's what we call diffusion. And then we will have a new substance called a solution of 2 substances. The same can happen with gases as well. This is because it's made possible because liquids and gases particles are mobile, can move, unlike the particles of solid. Now, diffusion, by definition, is slower in liquids. The reason is because the spaces between the liquids are smaller than the spaces between the gases. To the next slide. Okay, colleagues, the particle model of matter, it can be defined in different stages. To understand what is the model all about, we talk about particles first. Matter is made up of indivisible particles, and you'll see there's a diagram of showing you all those particles that I'm referring to. The particles can either be atoms, molecules, or ions, depending on the substance. And then the model of matter can also be defined in terms of spaces. You will see, as I moved on to this point, there are arrows that are in between those particles. Those arrows, they represent the spaces that we find between the particles of matter. But as you will see, I'm trying to demonstrate the space between the particles using the double arrowheads. The spaces are never really that large in size. I've just made them larger so that we can see there are spaces, but in real life, they are so small, we can't even see them with a naked eye. So it says here the volume occupied by the particles is much smaller compared to the volume of the entire substances, meaning the spaces between particles is so small that when we compare all the spaces added together against the particles, we'll find that the particles, they comprise a larger percentage, and then the spaces are so small. Okay, the other thing about particle model of matter is about motion. Those particles they don't just exist there, they are always in motion. In the case of a solid, they vibrate. And then in the case of the liquids, they rotate. In the case of gases, they move randomly within the substance. So the motion increases with temperature. If you boil water, the spaces are gonna be bigger. If you're gonna boil a gas or heat up a gas, the spaces between the gas will become even bigger. If you heat a solid substance, it will vibrate, the particles will vibrate more. Okay, the other thing about this model is that the particles, they don't just exist, because if there were no forces between the particles, they would move apart and move away from one another to infinity. It means they can disperse. But because there are forces between the particles of a particular substance are kept together. So the substance cannot disintegrate or fall apart. So particles interact with each other through forces. These interactions determine the behavior of the matter. The other thing is about, because of the other 4 points that I mentioned above there, about the particles, the arrangements, the space between them, how big the spaces are, the motion, what type of motion takes place, the forces, how strong are the forces, it can affect the behavior of matter. Now it says here, matter with large spaces between particles can easily be compressed. For example, I've just said that the gases have got the largest of the spaces. So the gases are easily compressed, or they can be squashed. They can be moved from a larger container into a smaller container. You can just think of the gas that we use to heat, to warm ourselves up, that we use to burn our geysers, our heaters, and so on. It is a compressed gas. So it means the spaces have been, the gas has been compressed or squashed. Diffusion occurs easier in matter that have large spaces between particles, meaning diffusion, if it happens, it will be much easier happening in gases. And then the next slide. Okay, because of the particle model of matter, matter can exist in 4 forms. Actually, in our schools, we only learn only the 3. The particle model explains the different states of matter based on arrangement and motion of particles. The states of matter are as follows: solids, liquids, gases, and plasma. We are not going to discuss the one about plasma because it's outside the scope of the grade 8 learners. The 3 primary states of matter that we are going to be discussing are solids, liquids, and gases. Okay, let's start off with the solid phase. Colleagues, to describe a solid phase, it says here, the particles in a solid are closely packed. Those are the characteristics. They are closely packed, as you will see on the left diagram. It means all those atoms are closer to one another. They are closely packed, and then they also give us a fixed arrangement or a fixed pattern. The particles also have small spaces between them. That is why you can't see actually between the spaces there, because they are so close together. If I were to put the very same solid phase and put it in a beaker, that's how it would look like. The solid would not fill the rest of the beaker, but it will only occupy a certain space within the beaker. Solids have definite shape and solids have a definite volume. Let us look at the diagram here of a cube. A glass cube here on the third diagram here. There's a set. There's a glass cube which is outside the beaker. You see the shape of the solid substance outside the beaker is the same as the shape of the solid substance within the beaker. It means solid substances always maintain their shape. They don't change their shape. And then the amount of space that this cube was occupying has not changed by moving it into the beaker. It means that it is still occupying the same amount of space. The particles of a solid, they vibrate around fixed positions. Now the motion of solids, it means they just vibrate. They move to and fro consistently around a fixed position. The particles attract each other with a strong force. That's why it is not easy to separate the particles of a solid substance. The particles cannot be compressed. It means you cannot squeeze a solid substance to make it smaller. So you can't compress it. The reason is because there are very small spaces for movement. So they can't be squashed or made smaller. The particles of a solid also cannot diffuse. The only time when you can diffuse the particles of a solid, it's only when you turn it into a molten solid, and it will no longer be a solid. It will fall under liquids now because the particles will be flowing. When you treat a solid substance under heat, maybe you heat it beyond 200 degrees, 600 degrees, it can melt, but it won't be referred to as a solid. It will be a molten solid. Okay, examples of the solid substances, for example, ice cubes that we get in our fridge, a block of wood, or even a metal. Those are the examples that we can just give out as examples of solid phases. Now the liquid phase. Okay, let us look at comparing it to the previous slides. The liquid phase, the particles in a liquid phase are closely packed as well, but they are loosely arranged. So the spaces, if you can even look at them, the spaces are still small, but they are larger than those of the solid substance. The particles have small spaces between them. Now, if you take liquid substances, because they have small spaces between them, the particles of a liquid are able to slide past each other, and we can say they flow. Now, if you take a liquid and you put it into a volumetric flask, like you see, it's 200 milliliters, and you transfer the 200 milliliters into a test tube, you see what happens here? The volume of the liquid doesn't change. It will remain 200 milliliters and also 200 milliliters on the other side. The only thing that appears to be having the shape that you saw of the liquid in the volumetric flask has changed. That is why it cannot have a definite shape. So the liquid will always take the shape of the container that they occupy. So if you put it in a flat basin, it will just take the shape. The volume will remain unchanged, meaning the amount of space that is occupied by the liquid substance will remain unchanged. Okay, the particles in a liquid, they move past one another. As a result, we use the term liquid flow. It's when the particles, they move past one another. The particles attract each other with a weaker force. That is why you can pour water in a glass beaker. The particles of water or the molecules of water, they won't leave that water in a beaker, because there are forces that are holding all the molecules together, or all the particles together. The only time when the particles of liquid can start to move away from one another is when you start to boil the liquid, meaning you're breaking the forces between all the molecules. The particles of a liquid, just like that of the solid, cannot be compressed. You can't squeeze it, meaning you can't pour 200 milliliters of this substance into a container of 150 milliliters and you expect the whole liquid to occupy that space. It cannot. Particles of liquid can diffuse. They can move between the spaces of each other. Okay, what about the gas phase? And examples there is milk, water, and oil. Examples of liquid substances. Okay, let's look at the gas phase. Right, when you proceed to the gas phase, you see now that the particles are much more spread out or further apart. As you can see in the diagrams below, the particles in a gas have very big spaces between them. Now, something that is new now, look at the container below, the small container having the particles on the right, having the particles of a gas. You can actually count the particles. There is 2, 4, 6, 8, 10. Notice what happens if we transfer the particles of this gas. This gas is consisting of 10 particles. If we transfer it into a larger container, the particles, they even spread further. So that is characteristic of the gases. Gases have no definite shape. They will always fill the entire space available to them. Even if you can transfer them to even a bigger container, they will also spread as long as they can cover the whole space. Gases have no definite volume. It means volume, remember, it is the space that can be occupied by any substance. Now you see in the small container, the volume or the inside of the container is very small. So the gas was put in a smaller volume. In a bigger container, the gas was put in a bigger volume. It will always try to match that volume. Now, lastly, the particles in a gas move freely and quickly. The particles attract each other with the weakest force. The particles can also be easily compressed, and the particles can also diffuse. Examples are oxygen, nitrogen, and carbon dioxide. Such gases, they can be compressed. Okay, Elenas and the colleagues, let us just come to the conclusion or the key points about today's lesson. We have been talking about the three primary states of matter, which is solids, liquids, and gases. Now, the three states of matter can be distinguished from one another in terms of the descriptors on the left, which is the arrangement, the motion, spaces, force, and behavior. Let us start with the arrangement. With the arrangement, just as a summary, particles in a solid are closely packed and are always in a fixed arrangement. Particles in a liquid are close together but are loosely arranged. Particles in a gas are not arranged in any particular way. What about in terms of motion? The particles move about their fixed positions, meaning they just vibrate. They don't move away from one another. They just make to and from movements. Particles of a liquid, they move faster and slide past each other, meaning faster than the solid. Particles of a gas, they are the ones that move the fastest. Spaces. Let us look at the spaces. Solids. Particles have small spaces between them. What about liquids? Particles have small spaces that are larger than in a solid. And then the gases, particles have very big spaces between them. In terms of forces, forces of attraction between particles are very strong in the case of solids, and they become weaker as we go to the liquids and become weakest as we proceed to the gases. And how do all those descriptors affect the behavior of the three states of matter? The particles, because of all the descriptors there, the particles cannot be compressed of a solid, and there is no diffusion in solids. The particles in a liquid cannot be compressed, but the diffusion is faster than with the solids. And then gases, the particles can be easily compressed, and the diffusion is the fastest. That concludes our lesson today, learners. The next QR code is for the assessment as well as the link. Thank you very much.